Hello, everyone, and welcome to another presentation in my series of debunking climate change. And in this episode, we'll be looking at demystifying science, the first step to debunk scientific hoax. In this presentation is mainly for the segment of the population that is not scientifically knowledgeable and minded, and it will take a very specific look into the various level of science from the very fundamental particles, atoms, all the way up to applied science. So sit back and relax and enjoy this presentation, as it will open your mind as to what is important and how science operates and how we can use science to literally debunk the scientific hoax, especially climate change that we have been exposed to for the past 8 to 9 uh, decades. In this slide, we will be answering the question of how do we see the big picture. One can only see the big picture by first understanding and examining the parts that make up the big picture. Just like a scrambled jigsaw puzzle, we have to each and look at each individual part and then see which fit in the puzzle. And with time and patience, eventually the puzzle start coming together until finally all the pieces are in place. Then the big picture will be fully appreciated. Science is just the same as any other puzzle. Take the time to understand the basic and fundamental, and you would yourself be able to make solid judgment on what is scientifically possible or not. You need a strong grasp of the basic if you want to understand or master the complex and advanced. What are the scientific fundamentals? Science is stratified into various levels, and they are as follows. 1. The subatomic, which is basic to all elements. The atomic and molecular, which determine the type of matter. The scientific property, matter of matter, compound or substance. Scientific observation, experimentation, determine what is scientific possible based on these properties. Scientific principle, laws, theory, determine what is possible and probable. And finally, the application of science. We will now look at the subatomic level and properties. At the subatomic level, you would find information such as the descriptive properties of the nucleus, electrons and protons, valency shells, electron volts, atomic mass, quantum mechanics, nuclear fission and fusion, and finally, ionization energy. The atomic or molecular level and the properties that we should be looking into. At this level of scientific understanding, you would be exposed to factors that affect the essence of a particular matter, whether it exists in single or polyelemental form, whether it exists in single atomic or polyatomic form, whether it exists as in a molecular form, what type of intra or molecular bonding is present between the atoms or molecules, be it ionic, covalent, metallic, or any combination thereof. The electronegativity of the atom or molecules involved in the substance. The polarity of the atoms or molecules, non-polar or polar, or degree thereof. Whether the substance is whether there is presence of intermolecular bond between the individual atoms or molecule. the atomic or molecular mass of the atoms or molecules involved, the size of the atoms or molecules involved, and finally the relative density of the atoms or molecules. These are just some of the properties that we usually associated at the molecular and atomic level of scientific understanding. The next level of scientific understanding, the next level up is to determine the type of matter. The atomic and molecular properties determine whether the matter exists as a solid, liquid, or gas, and at what temperature range and pressure. Whether it exists as a metal, a non-metal, or a metalloid, which is a combination of both metal and non-metal. A monoatomic, molecular, ionic, or intermetallic or complexes. Whether it exists in its elemental form as a compound or as a mixture. Whether it's an organic or inorganic compound, whether it's an acid, salt, or base. Here we'll be looking at the scientific property level of scientific understanding. The type of matter then determines its scientific properties, which are subdivided into the following groups: the physical scientific properties, the chemical scientific properties, and the thermodynamic scientific properties. We will now be looking into an in-depth look into the physical scientific properties. A physical scientific properties is a characteristic of matter that is not associated with a change in its chemical composition and includes some of the following: the state that it exits at standard room temperature and pressure, example solid, liquid, or gas; its color, taste, smell, or mechanical properties; its density; the melting point and boiling point of the substance; its dissolvability in water or lack thereof; and the electrical conductivity of the substance. These are some. There are more physical properties, but these are some of the main and common physical properties that you will encounter as you study the physical properties of matter. We will now be looking into some chemical scientific properties. These are scientific properties related to its ability to engage in chemical reaction and its ability to change from one type of matter into another, and includes some of the following properties: flammability, or its ability, how easy it is to catch on fire; toxicity, how dangerous it is to living matter; acidity, corrosivity, reactivity, oxidative states, chemical bonding, heat of combustion, and radioactivity. These are some of the chemical properties that you find associated with matter, certain matter, and this is the level at chemical scientific properties understanding of matter. We will now be looking at the thermodynamic scientific properties. These are scientific properties that can be considered as subject of physical scientific property, but deal exclusively with how a substance handles heat and thermal energy, and includes the thermal conductivity, the specific heat capacity, the melting point, and the boiling point. Here we'll be looking at some of the scientific principles of the scientific principle of scientific understanding. Knowing the scientific properties and principles of matter now allows us to formulate an exhaustive list of scientific theories, laws, and principles based on matter interaction with each other in nature and in our laboratories. And such scientific principle includes the Archimedes principles, laws of conservation of energy, laws of universal gravitation, laws of thermodynamics, laws heat, laws of heat conduction, the Einstein relativity theory, law of electricity and gas laws, and finally the mathematical laws that put them all together. Scientific experimentation. Scientific experimentation is a bedrock of the advancement of science. Some of the important means of scientific experimentation includes tests. We have to run the tests. Observation, very important. A lot of people observe, start scientific investigation experimentation by just being observed, by just observing nature and trying to understand what is going on. Trial run. Sometimes to attain a certain information, we have to do several trial runs to come to the facts of the matter. Examination, studies, and finally analysis. Analysis involves putting information together and see what actually if we can actually see a big picture or a pattern emerging. So these are just some of the ways in which scientists actually do experimentation to come to the truth or to expand our scientific knowledge. We will now be looking at applied science. Applied science is the use of scientific method, knowledge, and conclusion obtained from natural science to attain some practical goals. The only goal of basic science research is to increase the knowledge base of a particular field of study. Applied science uses knowledge base applied by basic science to devise solutions, often technological, to specific problems. Some of the main branches of applied science include the following: aerospace engineering, agricultural engineering, architectural engineering, biomedical engineering, civil engineering, computer science, mathematics, mechanical engineering, molecular biology, and statistics. So the field for application of science is almost endless and intertwining and interrelated. And as time goes by, this body of knowledge increases exponentially. Here we'll be looking at answer the question as to why the topic of climate is so elusive to many of us. Climate science is so elusive to many of us because of the multitude of interacting, complementary, and sometimes competing factors and variables that goes into the formulation of a specific climate, and it includes the following. One, the atmospheric components such as nitrogen, oxygen, carbon dioxide, water vapor, and cloud, and their interaction with the sun incoming infrared radiation. Two, the almost inexhaustible list of Earth's surfaces such as desert, hot and cold desert, jungles, woodland, forests, mountain, lakes, grassland, and the list goes on. almost inexhaustible list of Earth services. 3. Revolution and rotation of the Earth itself around the Sun and the season it produces. And 4. The shape and tilt of the Earth that also affects the amount of sun or and heat and the area received around the year. So all these various factors, these 4 factors, go together to make the science of atmosphere climatology a very complicated and broad-based scientific field. And this is a reason why it is easy to formulate schemes and hoax because it is so complicated. And this allow the possibility for scheme to be formulated and used against us. And as we can see in the climate change hoax due to the burden of fossil fuel, these climate so-called climate scientists that is exposing the schemes and this hoax know that most people will not take the time to investigate, let alone understand this broad and very complicated um, scientific field. How can we make understanding climate simple and identify climate hoax? We can make understanding climate simple and then able to identify climate hoax by going back to the basic of science and learning the scientific properties of the components of climate and weather, and the scientific law by which they obey and which bound them together. First step. Secondly, by conducting comparative analysis of all the components in regards to the relevant scientific properties or scientific principles, we can see not only the big picture clearly, but also insight into what is possible or probable in regards to the climate ourselves. And finally, by becoming and remaining independent of the climate scientists to dictate to us about climatic issue, along with holding them accountable and responsible for their pronouncement and assertion that does not conform to the basic and fundamental climatic sciences properties and principles. So this is how we can actually simplify and identify climatic hoax. If it doesn't abide by basic and fundamental scientific laws and properties, it is a hoax. It has to be a hoax. It has to pass the scientific sniff test. In conclusion, the following points can be made. Science was not as intimidating as it was once perceived. I hope that is the case for most of the viewers of this presentation, that science was not as intimidating as it once was perceived. Secondly, that we don't need to have a degree in science to actually understand and appreciate nature for ourselves. But all that is needed is a little investment in our time. Having a basic understanding of science pays enormous dividend in appreciating and understanding the wonders and intricacies of nature itself. We learn to appreciate science more when we have a basic understanding of science. And finally, to understand science, that in understanding science of nature, one can also see that science is not in opposition to the belief of a God, but clearly supports a belief in God. In understanding basic science, we can see how harmonious nature is, and that each element, each component of elements of our nature work with each other to accomplish the goal of providing life on earth. Many interactions, many dependency, many interrelations, that makes it all possible for life to be on Earth. Thank you very much. Please look forward to my next presentation. I have quite a few coming up in the next few weeks. I hope you'll enjoy them all. Thank you very much. Bye.